Brock, when can you make up the test? You're going to have to? You were out for a couple days in a row, right? Okay, Monday, what period? Okay. Limits is really the intro to basic calculus, and I think you'll find this pretty easy right now. When you're asked about the limit of a function, so first of all, let's talk about how to read this. You're being asked for the limit of the function as x approaches 4. So that's a little right arrow there. And you would read that as x approaches 4. So I'm just going to, above a, kind of write that in words so that you remember. The limit of function f of x, which is the function we're looking at a picture of, as x approaches 4. And a synonym, I guess I would say, for limit is intension. So above that, I'm going to write intention. So the graph might not actually ever get to the value that it's approaching. And when I talk about the value that it's approaching, I'm talking about the y value that it's approaching, as its x value does this. It might not actually ever get there, but it's like intending to. So if you're looking at 4 on this function, as the graph approaches 4, and you kind of have to look at from both sides. So from the left, I'm coming in this way, and from the right, I'm coming in this way. As I approach 4, it's pointing in that direction, and as I approach 4 coming from the other side, so even though that's an open circle and the graph actually never gets there, the intention of the graph is to get to that value, which is what? 7. So that would just be 7. Now, like I was just kind of saying, the function value at 4 is not 7. At 4, the function value is down here, 2. So they don't have to equal each other. Sometimes they will, sometimes they won't. Okay? Did you? No. Try C on your own. What do you think the limit of this function is as x is approaching -2? Anybody disagree with Ryan's 5? Good. And what is the function value at -2? 3. All right. Try E on your own. Think about that. What is the limit of this function, or the intention of the function, as x goes towards -infinity? In other words, what are the y values doing as the x values go towards -infinity? -infinity. Good. And same in f. What are the y values doing? What is the function doing as your x's go towards +infinity? What'd you say? -infinity also. As your x's move right, your y values are still going down. So your y values are still going towards -infinity. Yes? You know what you did do last year? You did end behavior. And the notation that's used in end behavior does come from this. Yes. So you would do things literally like this. As x approaches -infinity, y approaches -infinity. That is a limit concept. It is. So I take that back. You did. And then you would say, as x approaches infinity, y also approaches -infinity there as well. So that you did end behavior. So yes, you kind of did do this without that notation. Good memory. Good thought. All right. Okay. And then there's such a thing as one-sided limits. So you could be asked, and let's just jump right down to the example. I hate starting with notation. It's just so much more confusing than it's worth. What this one is saying is as x is approaching -2, you're going to notice a superscript up to the right. Do you see it? That's a negative sign. That technically means from the left. It's either going to be a negative sign or a positive sign. A subscript is something that's written below, and a superscript is something that's written above. Like exponents are superscripts, but they mean what you know an exponent means. A negative sign as a superscript up here means from the left. So we're looking for the intention of the graph as x approaches -2 from the left. So I'm going to do this up top just to take that note for you. If I'm approaching some, I'll just do 2. That means 2 from the left. And with a positive superscript, I'm not saying exponent because it's not technically an exponent. Exponents mean to multiply something by that number a certain number of times. So 2 to, like with a positive superscript, means 2 from the right. So what is the limit of this function as x is approaching -2? So here's -2 from the left. From the left, what's the y value getting closer and closer to? 0. Good, Maya. If I approach -2 from the right, so look on the graph, and I just need to get just to the right of -2. I don't need to go way over here. I want to get infinitely close to -2, but coming from the right. What's the y value approaching? -2. And so here's this new concept. If it's approaching something different from the left versus from the right, and these two disagree with each other like they do here, the overall limit does not exist. So if someone just point blank says, what's the intention of the graph as it approaches -2? You can't quantify that because the intention from the left is different from the intention from the right. So the overall graph doesn't seem to have an intention as it's approaching -2. Generally speaking. One-sided limits exist, that's fine. But if they don't agree, then the overall one doesn't. See, up here, we didn't have that problem. I know we weren't talking about one-sided limits up here, but we were approaching 4. And from the left, it was 7. From the right, it was 7. So we just answered 7 because it was pretty clear that that's what the graph's intention was. Does this make sense? Okay. And then the function value at -2 is what? -1. That's just where the closed circle is. Okay, go ahead and run through your 4 on number 2. Mike, what'd you get for part A? Did anybody get anything different? -3. -infinity. Okay. We're approaching an x value of 1. So the x value of 1 is occurring right here. Everybody see that? As my x value gets closer and closer to 1 from the left-hand side, what's my y value? 0. Mike was correct. So share with me where -3 came from. So, but you're looking at an x coordinate of -3, so that's what you would be doing. But x wasn't approaching -3, so your eyeball, as soon as you see what x is approaching, focus in on that vertical section. Does that make sense? Which one did you use? The left, the middle one. But this. So immediately go to what. So if someone asks you about the limit as you're approaching -5, you're looking here. Go right to that number on the x-axis and see what the y-coordinate is doing as you come at that from the right and from the left. But this was 1, so we're looking here. So from the left, the y-coordinate's approaching 0. From the right, what's the y-coordinate approaching? 0. Do those agree? Yes, so that's 0. So the overall limit therefore exists. And what is the function value there? F of 1 is also 0. So that's a case where they're all the same, which will mean something, and we'll talk about that. But so going back up to the top, this is essentially what all this says. This is saying that your overall limit as you approach A will only equal some value L if and only if the limit as you approach from the left equals L and the limit as you approach from the right equals L. In other words, like down here, the only way this one's going to exist is if these two agree. Number 1, they have to exist, and number 2, they have to be the same number. Over here, we saw that that did not happen. The overall limit did not exist because they both existed independently, left and right, but they were different numbers. But they would all have to be the same L value in order for the overall limit. So you'll hear me say the limit from the left, limit from the right, and overall limit to kind of encompass what I'm trying to say. It's not really math perfect, but like it hits home what I'm talking about. And then the second part just says that we can kind of use this to show why an overall limit would not exist. We can find it from the left, find its number, find it from the right, find its number. They're different, therefore the limit does not exist. And that's what happened in example 1. Okie doke? All right, so I'm ready to give you your homework, and you start working on it now. And you can probably finish it now. You have 25 minutes. Here. Oh, you're the best. Yes. You're doing all of it. There's not any really much written work. It's all looking at the graph.